My name is Gavin Newlands, and I'm part of the development team who works on Oasys PRIMER, and I'm going to be going through the webinar today. So I'll just do some introductions. I'll go through the purpose and a little overview of PRIMER. And then the focus is mainly going to be on model checking in QA. So I'll talk about some core model checking tools. I'll talk about some other PRIMER tools that can be used for checking models. I'll talk about tools which maintain the model integrity. And towards the end, I'll talk about customization of checking. And finally, I'll talk about integrating PRIMER with some of the post-processing tools that help to aid checking your models. So just a little bit about us. We distribute LS-DYNA in the UK, China, and India, and we have over 30 years of experience of working with LS-DYNA and LSTC. So we have access to the LS-DYNA code, which allows us to develop our own functionality for use by ourselves and for our clients, as well as fully understanding all LS-DYNA keyword data. And we also provide support in LS-DYNA to clients around the world, which helps us to understand LS-DYNA and understand the trends in its use, as well as trends in automotive CAE. Just a little bit about the software. So as well as supporting LS-DYNA, we produce the Oasys software, which is what you see on the screen here. So we have our preprocessor, which is PRIMER, which is a preprocessor designed for LS-DYNA. And then we have THIS, D3plot, and Reporter, which are our post-processing packages. So today I'm focusing on Oasys PRIMER. Can I just check? Can people hear me? I've got a message saying that people can't hear me, but are you able to hear me? If someone can hear me, can they just reply in the questions box to say yes? Okay, so people can hear me. Good. Okay, thank you very much. Yeah, that's confirmed that you can hear me. Thank you for those messages. Thank you. Okay, so I'll continue. Talk about PRIMER today. And so PRIMER is a specialized preprocessor used for LS-DYNA models. It's comprehensive modeling tools and error checking help reduce preparation and debugging time for LS-DYNA models. It's fully compatible with the latest version of LS-DYNA, so no information is lost when reading or writing out the model. And PRIMER's model management tool allow your team to work in parallel on different components of the model. And because of PRIMER's robustness and depth of understanding of the LS-DYNA data, users tend to trust PRIMER to work with their complex models without corrupting or losing any data. So moving on to talk about model checking and ensuring the integrity and quality of your model. So when we're talking about checking an LS-DYNA model, we could very basically split it up like this. So you've got your model, you do some checking before your analysis, when you're building your model, creating your model. You might do some checking when it's running during your analysis. And you could also do some checking post-analysis as well. So pre-analysis checking is what we're talking about in the first instance. So core checking features, first of all, in PRIMER. First of all, I want to talk about the main core checking tool. So this is when you open up PRIMER, you read in the model or create a model, you can go to check and apply. Now this webinar is a mixture of slides and demos, so I'm going to switch into PRIMER. So hopefully you can see PRIMER now. And the main checking tool is under Tools in the top right-hand corner. You click on Check, and then you click on Apply. So this runs the model check, the main model check on PRIMER, and you get a results that look something like this in a tree view. Now there's over 7,000 individual checks currently in PRIMER. So when you run a model check, PRIMER is running those on the appropriate entities and giving you the results. If I expand this slightly, you can see that the results are split into errors and warnings. Now, it's somewhat arbitrary as to what's an error and what's a warning, but we determine what's an error and a warning based on our experience of using LS-DYNA and feedback that we get from the users of Dyna and Primer. So errors are generally things that either will cause LS-DYNA to error terminate, so won't run, and they could be simple things like entity A refers to entity B, and entity B doesn't exist in your model. Or there could be other things that we think that might not cause LS-DYNA to fall over, but through our experience is something that's wrong in your model, and you need to fix them to have a correct model. So if we just look at some of the examples here, we have an error under defined curve, and this is an example defined curve reference but not defined. So this is a curve that's referenced by something, but it's not defined in your model. And I can see that if I edit that curve and look at the cross references. I'll talk a little bit about those later on. But here we have a material card, map24, and as you can see in the LCSS field, it's referring to a load curve that doesn't exist. There's various other examples here. Nodal rigid bodies, constraints. So these ones here, separation of rigid body exceeds user-defined tolerance. Dimensions of nodal rigid body exceed user-defined maximum. These are user-defined checks, and I'll explain a little bit more about those later on. And there's a few checks here for constraints. And so here we have problems where we have a constraint type tied contact, and it's clashing with rigid parts or other constraint definitions. And when we have these constraint problems, that can cause problems in LS-DYNA. Looking down at some of the warnings, control. Sorting flag for degenerate quads, eSort is unset. Now, some of these will have the ability to automatically fix these problems. And when you have an auto fix, you'll see an F next to the item here. So you can hopefully see with the control entry here, sorting flag for degenerate quads, eSort, there's an F next to where it says shell. This means I can auto fix this. So if I right click and go to auto fix, it's performed a fix and it's set the eSort value to 1. And now that's been fixed and therefore disappears from this check tree. Now, from this check tree, you can also obviously sketch things. So if I'm looking at some nodal rigid bodies, I can obviously sketch where they are in the model and investigate them further. And you can delete entities and so on. So let me go back to my slides. I've got some slides here that show a typical output from a model check and the different types of errors and warnings that you might see. So you can see here we've got some of these multiple constraint errors where we've got some constraint definitions clashing with each other. This is this load curve reference but not defined. These blue ones, user-defined check. I'll talk about those later on. We have quite a few checks and warnings built into material data, map24. Obviously, those are quite popular materials, so the more popular materials, we have more checks. Warnings. So warnings are things that aren't necessarily going to cause a problem in your model, but they're things you need to be aware of and maybe consider doing something about. So things like element quality falls into that category. And so on. Elements of rigid part are not continuously meshed. Again, it's not going to cause your dyna analysis to fall over or error terminate, but it might be an issue in your model that you need to be aware of. I'll talk a little bit more about mesh quality now. So we've got tools available in Primer for obviously you check all your elements for the quality criteria that you have specified. You can also contour elements according to quality, and also contour elements that fail specific element specified criteria. And you can move nodes both manually and automatically to improve element quality, split, combine elements, that sort of thing. Now I'll just switch into Primer just to show you something that you may not be aware of that you can access. If I just open up a smaller model here, I've got a model with just a bonnet in here. Just rotate it around. So if you go to model check, if I turn my element quality checks on, so this is under settings, you can turn on what your criteria are and set them to whatever you want. Next, near the apply button, there's an element quality option, and this opens up the check tree in a special mode where it just shows you the failures for element quality. So you can investigate the shells that have failed, Jacobian, for example. Now, also in this panel, you can plot quality imperfection. So I'm just contouring that now. This is an overall aggregate score where all the quality criteria are combined and give you an overall score on the quality of your element. And so the higher the value, the worse the element is. I can also, if I want to, just plot or contour the elements that have failed the criteria that you have set. So here you can see there's some red ones here that fail the minimum length criteria, and there's some blue ones that fail the skew angle criteria. And then also through this panel, there's a node drag button where I can manually click and drag on those the nodes and help to solve some of those element quality problems. Now I want to skip ahead a little bit and talk about writing out a model, because you could just write a model out and not think about doing checks at this point, but it's quite important to do checks before you write the model out. Now, one such check is when you write a model out, you specify the version of LS-DYNA that you're going to run your model in. Okay, so in this example on the screen, you can see that the version is set to R10. So that means you're going to run your model in R10. Now in Primer, Primer knows for every keyword and every field on every keyword when that was added into LS-DYNA. So it knows when a particular field was added in, let's say it's added into R10 or R11, it knows that. And that means that if you're using a keyword or a field or a setting on a field that was only introduced in, say, R10, and you're running in R9, then that's going to cause a problem because LS-DYNA will not know about that keyword or setting or field. So when you write your model out, Primer will check all this and it will give you a warning if you are trying to use a keyword that isn't supported in the version of Dyna you're running in. Okay. So to try and summarize that in a bit of a diagram, let's say you've got an LS-DYNA model where you've got keyword 1, 2, and 3 in there. Let's say keyword 1 was added into R6, keyword 2 was added into 960, keyword 3 was added into R7, and keyword 4 was added into R9. Let's say you want to run in R7.1.3. So LS-DYNA will likely not run because this keyword 4 is not supported. Okay, so when you try and run, if you have this model in Primer, you try and write it out in R7, then Primer will give you a warning and tell you that you're using a keyword that's not supported in that version. Now, up until the most recent version of Primer, you only got this information when you tried to write a model out. And it's sort of slightly annoying that you only found this out when you're trying to write the model out. This has now been built into the main model check. So if you have any issues like this, then Primer will find it when you run a model check. So the tree view that I showed you before, it will show up in there if you're using a keyword or a field that's not supported in the current version of Dyna that you have set as your current version. So another thing when writing a model out, if you're working with include files and you're writing out your model, it's quite wasteful to write out all your include files every single time, because you might have just changed the contents of 1 or 2 or 3 of your include files. So because of this, when you're writing out a model containing include files, there's a Find Modified button. And what happens here is that when you click on it, Primer will compare your current model against the model that was read in the first place and look for any differences and tell you what those differences are. So let me just demonstrate that. So if I go back into Primer, let's say I modify a node on the roof here, and I'm just going to set the coordinate to be something else in the Z direction. So you can see my roof, hopefully you can see my roof has been modified and I have a node that's now in space above the car. If I go to Model, Write, I'm going to select the include files I want to write out. So you get a view like this, list of all the different include files, and I want to know which ones have changed, so which ones I want to write out. So if I click on the Find Modified button, Primer checks the current model against the one that was originally read in and highlights the differences and highlights the include files that have changed. So here it's saying there's two include files that have changed. One is the control card, the one containing the control cards, and one is the body and white. And in this tree view that pops up, it tells me what the differences are. Now, this is telling me that control shell has changed and a node has a different coordinate. And this makes sense because I have actually changed two things in this model. One was the nodal coordinate that I've just changed where I moved the roof node further up. And the other one, if you remember, I did an autofix on a control shell card when I was showing the check tree. And that set the eSort value to be 1 from 0. So that's a difference in the model. So now I can select to just write out those include files, write out a new master file, and I don't have to write out any of these other include files because they haven't changed. So this is also, as well as deciding which include file to write out, it's also a useful thing to do at the end of your, just before you're about to write it out, just to double check what changes you've made and whether they are what you expect them to be. Now, this functionality is not just built into the writing out panels. It's also available to you in a generic model comparison tool called Model Modified. And you get to this from the Model tab, and you click on Modified, and you specify the modified model, which is usually a model that you have read into Primer. And you can compare that to either the original, so that's the original file that you read in, or another model that's in Primer, or maybe a file on disk. And there's various options in here. And if I just open up Primer again, so here I'm again looking at a vehicle, but actually if I go to model list, I have two models read in on top of each other, and they're very, very similar, but they do have a couple of small differences that I've introduced so I can demonstrate this model modified tool. So if I go to modified, I'll just collapse these so you can see the whole panel. And there's various options in here, as I said. So if I select the modified model, model 2, and I'm going to compare it against model 1. And there's various options down here, and I'll not go into any detail about these, but I'll just briefly describe what these ones down here mean. So there's options for comparing parts. So you can imagine that when Primer's doing this model modified, it's essentially comparing data on the keyword cards. But you can imagine for a part, the keyword cards could look the same. So they reference the same section ID, they reference the same material ID, and reference the same hourglass ID. But actually the parts themselves could be quite different because they could have a different mesh and so on. So this goes one step further by comparing part properties. And when we're talking about part properties, we're talking about things like part mass, smallest time step, number of elements, that sort of thing. Basically, any part property that's calculated and put onto the part table, it compares and tells you if there's any differences. You can also do some simple geometry checks, so it can check to see if there's any differences in geometry in parts. And then we've got options for comparing connections as well, which is quite useful. So what this does is it will, for model 1, it will look at particular connections, let's say a spot weld, and that's at a certain coordinate. And it will look to see if there's a spot weld that exists at the same coordinate in model 2. And if there is, then it will compare those spot welds and see if they are maybe a different material property, they're different diameter, and so on. So it will tell you if there's any spot welds missing across those two when it's comparing those two models. And also, if it does find matches, it will let you know if there's any differences in the spot welds it finds there. So if I just click apply here, now it's comparing the data across those two models, and then you get a tree view telling you what the differences are, and you can investigate these differences. So here it's telling me about nodal differences, and I sketched those. You can see there's a group of nodes which have different coordinates in the front of the vehicle. And parts, I can look at different parts, and this part here has got different properties, and I can open up the part table in the special mode that tells me the differences between those two parts. So here it's telling me the mass is different, and the C of G is different, and so on. This is also telling me the geometry is different for these parts. So if I have a look at the geometry here, it allows me to contour differences in parts. So hopefully you can see here there's a part where I've introduced a small mesh change, and it's now contouring the differences between those two meshes. So there's lots of information that you can get from the model modified tool, and it's a useful way of checking your model against the original model you read in, or maybe you have a reference model that you know is clean and working well, and you want to compare it against that to see what the differences are. I just want to talk a little bit about contact penetration checking and fixing as well. So we have a contact penetration checking tool in Primer, and when you do a penetration check in Primer on a contact, we split up the types of penetrations into two groups really. One is called penetration, and that is where a node is too close to an element, so within the contact thickness. And the other is a crossed edge, and that's an intersection where we have actual intersections between the element planes. Now it's important to note that Primer understands all the different methods of defining contact thickness that you can do in LS-DYNA card. So SST on contact, or maybe you use star part contact. And Primer also tries to use the same equations as LS-DYNA to determine penetrations. So our goal is that you should get the same answer as LS-DYNA in terms of penetrations. And as you may or may not know, that the penetration checking in LS-DYNA can be different between MPP and SMP, and so on. There's lots of different settings that go into determining whether you have a penetration or not. And we try to take all of those into account in our own penetration checks. So I'll just show you this very briefly in a demo, what it looks like. So I've got a very simple model here of a top of a B post, and I've got some penetrations in this model. So if I go to contact, if I look at an automatic single surface contact I have in this model, and I can run a penetration check on this, the panel I get looks something like this. And what we do is, because obviously with something like a single surface contact, you can have loads and loads of penetrations in your model. We split those up into different groups, and we group them by part pairs so you can visualize them in an easier way. So down here, I've got a list of 3 part pairs. I can click on these and have a look at where these penetrations are. So you can see here, this top one, it's saying I've got 5 crossed edges and 6 penetrations. And it's showing me where those penetrations are. And you can contour these things as well. So I can contour that and have a look at them. So if I look at all of them at once, this contouring is showing me the depth of penetration. So it's contouring the node and the segment that it's penetrating into, and it's telling me how far that node penetrates into the thickness of that, the contact thickness of that segment. So you can see where the worst penetrations are and so on. And there's lots of options here for changing how it's displayed. You can, by default, we display penetration magnitude, but you might want to have a look at how much thickness is remaining in that penetration, and you can look at ratio of thicknesses and so on. So you can do some various things and contour all this information in different ways. But let's say you now want to fix some of these problems. So let's just choose the first one here. If I go into the fix, there's a fix button on this panel. Now, you generally have either automatic ways of fixing problems or manual methods of fixing these problems. So for this one, I'm just going to show you some of the manual methods. At a very basic level, you choose the nodes you want to move and you decide the direction you want to move it in, and you move them. So here, I'm just going to drag one at a time, and you can see I can click on these nodes and move them down and solve those crossed edges and penetrations. If I go back and have a look at the rest of the penetrations I still have in the model, so I've fixed my crossed edges, but I now have some penetrations left. If I go to fix, and I'm going to do some, I'm now in the penetration mode. So now I'm going to apply an auto fix to this. So using the auto fix, Primer will iteratively move the nodes away from the segments to fix the penetration. So if I click on apply fix now, excuse me, sometimes you might have to do it a couple of times. You'll hopefully see that we're moving those nodes a very small amount to remove the penetrations, and now we have a penetration-free model. And there's various options on this panel for locking certain parts. So you might want to move nodes on one side rather than the other, and so on. So you can do that on this panel as well. Okay. So I just want to talk about checking during the analysis. So this is something you might want to do if you have initialized your model. You might have initialized your model and you want to see how it's getting on. And Dyna provides lots of useful information in the D3HSP file or the message files that are output. So it'll output some errors and warnings. And you might be trying to run your model and you get an error termination straight away and you've got some errors and warnings. You need to investigate that information. So the previous method with Primer of doing this would be to open up the text file, be it the D3HSP file or the message file. You'd open that in a text editor and you would find the error message, search for all error messages, look at the IDs of the entities that are going wrong, might have an issue, and then you come back into Primer and you try and find those entities. So what we've done in Primer is we've added in the ability to read these LS-DYNA output text files and more easily investigate this information. And actually, I'll show you this in an example. So here I have another vehicle model which has been initialized in LS-DYNA. And if I go to check, there's an option here called Dyna output. It's just below the red apply button. So I click on that. So what Primer does now is it automatically looks at the directory where you read the file from and looks for D3HSP files or message files. If it finds them, it then provides you a list of all the files that it can read, and you can turn on or off the reading of whichever files you want. Now, sometimes you might keep your keyword file in a different location to the output files. And for those situations, you can navigate to a directory to read the files that exist in that directory instead. So once you have the files that you want to read, you click Apply, and Primer scans through those files. It mines out information to do with the errors and warnings, and again, gives you a tree of information. So here at the minute, we're splitting this up into errors, warnings, and termination messages. So errors are the error messages, warnings are the warning messages, and termination are things like termination due to out of range velocities or something like that. Now, in this particular example, we have some warnings. So if I expand out the warnings, these are all the messages that you get in the output files, in the LS-DYNA output files, but we replicate them here. So hopefully you can see here, for example, this is the error code which is giving in the D3HSP file. There are strings with orientation vectors and finite lengths that may affect rigid body motion. So here, Primer knows that when it's talking about springs, it's talking about star element discrete elements, and it's mined out the information and determine what those elements are called. So I can now directly sketch where those are, and then I can look at them and maybe do something about them. So the ability to read all this information really makes it a lot quicker for you to investigate the errors and warnings that you have in these dyna output files and do something about them. I just want to talk about some of the other checking features in Primer outside the core checking tools. So there's lots of visual checking features. So first of all, contouring. You can contour various different things in Primer, and it's a really useful way of investigating certain information in your model. So I'll just go back into Primer and show this. If I go into back into this model. So the contouring is down in the view buttons at the bottom. These blue buttons which say CT and SI turn on contouring, and below where it says time step, by default it is where you can change what you're contouring. So if I click on CT, I'll contour time steps. This is element time step we're contouring at the minute. And you can investigate the bigger or smaller time steps in your model. And I can change this to other things, so things like shell thickness. In this particular model, I've artificially introduced some errors. So hopefully you can see, if I look from above, that on the right-hand side of the vehicle, we have a panel which is dark blue, whereas on the left-hand side, it's light blue. So that's indicating that there's a potential issue here in the model. And with these contours, I can click on particular bands and investigate the information. So if I click on the dark blue band in the contour bar, it's showing me just the elements in this case that relate to that contour bar. So you can see here I've probably got some null shells on my engine block. But it certainly looks incorrect that I have a panel of such a low thickness along the side of the vehicle and not on the other side of the vehicle. And you can plot various different things, shell normals, so you can check your shell normals. Element properties, so element formulation, number of integration points. So I can plot my number of integration points here. And you can check to see where they're set in the model and so on. Element quality, as I've mentioned before, all the different element quality criteria you can plot individually. You can plot the quality and perfection or the failed criteria, as I said before. Mass scaling, so you can plot added mass, how much added mass you have on a part-by-part basis and so on. It's quite useful for investigating where your added mass is. Material properties, density, yield stress, Young's modulus, and so on. So if I plot yield stress in this case, again, this is an example where I've introduced an error. If I zoom in, hopefully you can see that there's a part here which is different on the left-hand side to the right-hand side in terms of the yield stress. So there's probably a problem there, and so on. There's lots of different things you can plot. Now, next to the blue CT and SI button, there's a node plot as well. So this is for plotting things based on nodes, so things like initial velocities maybe. But also there's tools in here for plotting SPCs on nodal mass. So the SPCs are quite useful. So if you use SPCs, or maybe you constrain parts, rigid parts, then you can contour those, and we put a blob on that SPC, all those parts, and it allows you to visually see how they're constrained and in which direction, and whether it's a local or global coordinate system, and so on. Okay. So now moving on to the attach tool. This is a way of investigating relationships in your model and checking they are what you think they should be. So I'll just demo this interactively. And if I go back into my model. So attached is found under tools. And if I click on attached, what this does basically, it looks for things that are attached to other things. And so it'll look to see what's attached to what's visible. So if I just rotate my model around slightly and do an only on the roof, so we're just looking at the roof, I'll leave all the, there's various settings on this panel, but I'll leave them at the defaults at the minute. If I click apply, hopefully you can see that it's found some spot welds that are attached to this roof panel. And if I click apply a few more times, you can hopefully see that it's propagating out, finding things that are attached to the newly found items. So Primer knows about the relationships between entities and knows when they're connected or not. So this is an easy thing for things like nodal rigid bodies, which have a nodal connection. But then you also connect together things with tied contacts. And because Primer has a comprehensive contact penetration checking tool that I showed you before, it uses this to determine whether things are tied or not in a tied contact. And it understands all the issues that you could have with constrained type tied contacts clashing with rigid bodies that may cause those tied contacts to not stick. It understands all that, and that's all baked into this find attached tool. So you can keep on clicking apply, and there's various options on here for changing how this works. Now, one useful tool is the recursive tool. So if I turn that on and click apply, what's happening now is Primer's continuously finding attached, until, and it stops when it can find no more. So it can't find any more after 21 loops of find attached. So at this stage, if I reverse what's blanked and what's unblanked, so I can click on the reverse button here. This is now showing me the things that are left over that it couldn't find attached to everything else in the model. Now, this is a useful way of checking to see if the items that are not attached are what you expect to be not attached. So here you can see there's some bumper foam at the front of the vehicle that isn't attached, and you can maybe believe that that's correct. Maybe it's not meant to be attached. Maybe it's just sitting in space there. But certainly in the middle of the vehicle here, there's some accelerometers that aren't attached to anything. And here it looks like there's some parts of the door, latch reinforcement, for example, that's not attached to anything, and that's probably going to be a problem that you need to fix. A couple of other visual tools that you can use. Exploded view, which you find in tools, is a way of exploding the view. So you can explode the view by include files or parts sets in different directions. And it's a useful way of visualizing your model in a different way to see what the contents of your model are and how they relate to each other. And as part of that tool, there's a way of visualizing connections between include files. So here you specify sort of master include file, and Primer will calculate all the other include files that it's attached to and show you that in an exploded view. So here we're just looking at the body and white being attached to the fascia here at the front end, and it's showing it in an exploded view and showing where all the connections are. So it's kind of a useful way of visualizing the relationship between these include files and how they're connected, and a good way of checking that information as well. Cut section is a useful visual tool for checking information in your model. So if I go back into Primer, and let's just do a cut section. So it's under Tools. I can click on Cut Section. I'm just going to pick a node somewhere in the model. And it's created a cut section, so it's slicing through the model. So if I zoom in, the first thing hopefully you can see is that it takes into account in the cut section the thickness of the elements. So you by default will see the correct thickness of those elements, and you can see how they relate to each other. And it's a useful way of having a look at initial penetrations. And there are some initial penetrations in this model. If I zoom in, you can see this panel's coming down too low through this panel. And there's various interactive ways of looking at this cut section. You can turn on one side of it and turn off the other side. And you can interactively drag the cut section through the model back and forward. You can rotate it in different directions and so on. You can do a thick cut, which just does a slice through the model, and again drag that back and forward. So there's a few options on here which makes it easier easier to investigate a smaller chunk of your model without looking at the whole thing. There's also an option here, this Properties button on the cut section panel, where you can calculate certain elastic plastic properties of the cut section. So IXX, IIY, and so on. So that's available for you on the cut section panel. So find, there's a generic find tool in Primer, and this is there to help you find entities in your model. So sometimes your models are really, really big, many millions of elements, lots of data, and it's often quite difficult to find a particular entity if it's quite small, and then more importantly visualize it in some kind of context. So find helps you do that. So if I go back into Primer, and let's go to Find. So it's under the Tools menu in the top right-hand corner. If I click on Find, let's say I want to look for a constrained nodal rigid body. So I'll just choose the first one on the list here. So the first thing it does is it sketches where it is and puts a crosshair there so you can see where it is. So hopefully you can see that's put a crosshair around where that nodal rigid body is. But there's other things you can do in this panel as well. So I can turn on Only, and that will just display that nodal rigid body and blank everything else. Or you can do Only plus Attached. What that will do is it will display just that entity and what it's attached to. So it's useful for cutting down your model drastically and just seeing that entity in some kind of context. Or you can put a volume around that particular entity. So the center of that nodal rigid body, I've now got a volume, a sphere of a particular size, and I'm showing everything in that sphere. So again, it's a useful way of cutting that down and seeing it in some kind of context, cutting down your model and seeing it in some kind of context. Now, the volume option is useful for looking at smaller items in a big model. But what if you want to look at a bigger item? So let's say I've zoomed out in the model here, I'm looking from below. Let's say I want to have a look at this exhaust pipe. So if I click on Part, so there you go, it's sketched it. But in the most recent version of Primer, we've added in this surface option, which allows you to see the selected item in a different way. So if I turn that on, as you can see, it's just showing me that exhaust pipe part, but it's showing me everything that's within a particular distance of the surface of that part. So if I just increase that surface value to be 100 and zoom in a bit, you can now see that exhaust pipe, and it's showing me everything that's within 100 millimeters of the surface of that item. So again, useful for seeing something in a particular entity in some kind of context and cutting out the rest of the model when you're looking at it. This particular option, obviously useful for checking clearances and things like that. Checking include files. So many of you will use include files, and you have to work in a particular way with the include file to ensure the quality of your model. So when you're working with include files in Primer, we have the concept of current layers. So the current layer is displayed in green in the part tree. So here you go. Here's the part tree, and you can set a current layer, and that means that any newly created entity will go into that layer, and it allows you to manage the data in your include files. And you can move things back and forward between different include files in Primer quite easily as well. We have tools that allow you to specify numbering ranges for each include file. And this is a really powerful way of managing labels within your Dyna model, because obviously if you have clashing labels across include files, that will cause problems in LS-DYNA. So if you have a large team working on multiple include files, it's advisable to have numbering ranges, and you can bake those in to Primer. So you can specify them in Primer, and then when you write the model out, those label ranges are stored as comments at the top of the include file. So that means when you read the model back in, Primer will read them and use them again. And Primer uses these for lots of different things. When you're creating entities in a particular include file, it will ensure that the label that entity gets is within the correct numbering range. It uses it when you renumber your model. So if you renumber your model, renumber everything in your model, you can make sure that things are renumbered into the correct numbering range. And it also checks your model as well. So this is used in the main model check, and it checks to see if the entities that exist within include files have labels that are within the correct range. And if it finds that there's an issue, you can automatically renumber those back into range as well. Visualizing labels. This is just another visual check. I'll just demo this in Primer. And it might be something you're not aware of because it's slightly hidden away. But if you go to a model renumber, there's a visualize button. If you click on that, you get this panel. And this is a kind of graph view, a visual representation of the labels currently being used in your model. So all the rows, each different row is a different entity type. And across the top, you've got the numbering range. And you can move your mouse around and you get feedback for the different ranges. Now these black blocks represent label ranges that are currently used. So you can see this one here along the solid row. If I right click on that, you can do an only. And you can see that those solids in that numbering range relate to the solids in this seat model. There's various things you can do in this panel. You can zoom in and out. You can pan back and forward. I can click and drag these to renumber things and so on. And there's another mode you can view this in when thinking about include files. If I switched from entity mode to include mode, now down the left-hand side, I've got all the include files. And I've got the labels that are currently being used in these include files. This is a useful way for visualizing, what labels you have and where they exist within all the different include files. And if you have numbering ranges set, these appear as these sort of blue transparent blocks. And you can see here, there's an orange block, and that's telling me that there's some entities that exist outside of the numbering range. And these are actually the solid elements in the seat that I just renumbered. So I'll move those back into the correct range now. So again, it's another useful visual tool allows you to check your models in terms of labels. Deleting entities and maintaining model integrity. So this is, again, expanding on the idea that Primer understands relationships between entities. And so if you are deleting something, you can very easily introduce errors into your model. So let's say you're deleting a part. A part obviously refers to materials and sections and hourglass cards, but there are other things that refer to the part card. So for example, a part set, elements, constrained rigid bodies, they can all refer to a part card. So if you just remove that part card from the model, then that would introduce errors into your model because the elements would refer to a part that doesn't exist and so on. So when you're deleting entities in Primer, if I go into Primer again, let's go back to this model. If I go to remove, and let's say I want to delete a part, and I'll just choose one here, that one. When you try to delete it, Primer will look at the relationships to other entities and tell you the other things that need to be deleted to maintain the integrity of your model. So here you can see I've picked a part, and it's I'm going to delete the part, I'm going to delete the solids that are within the part, and obviously there's nodes within the solids, but also it's found some constrained entities that refer to that part, and those also need to be deleted as well. And because Primer knows all these relationships, it knows what it needs to bring up and only what it needs to bring up. And if you delete those entities, then your model will still be clean after that deletion. Now, moving on from that, you're probably aware of this, but cross-references or XREFs is something that's heavily used in Primer. And if you wanted to, these are the things that, let's take the example of a part again. So I've said that a part refers to section ID, material ID, hourglass ID. Then other things refer to that part. But from the dyna part card, you don't know that a part is referred to by an element or referred to by a part set. So Primer maintains these cross-references, and you can access them through the edit panel. You can click on this view cross-references. If I go into Primer again, for let's say this roof panel, I can click on view cross-references, and it tells me all the things that have a relationship with that part. So the part itself refers to material and section, as shown on the right-hand side. But then here you can see the parts referred to by beams, shells, a part set, and so on. So cross-references are a really important part of the relationships between entities and Primer, and they're used extensively both in terms of you being able to visualize and investigate relationships, but also in things like deletion and find attached. It allows us to completely understand those relationships and display the correct information about those relationships. There's various tools for investigating and creating mass. So mass is obviously something that is important in LS-DYNA models, and you often have to investigate and check the mass on parts or groups of parts and assemblies. So there's a generic mass properties tool that's under tools, and that allows you to select some entities, and Primer will calculate the mass of those entities and report the mass, C of G, and inertia of whatever entities you have selected. The part table is a useful place to look at part mass. So this is, the part table is something you can bring up where you get a row for every single part, and it displays various pieces of information about that part. And some of the information that you can display relate to mass. And you can consider mass in dyna in a variety of different ways. It might just be the structural mass that's calculated by the element and the thickness and the density. But also you might want to also consider time step added mass. You might also want to consider any star element mass part definitions that are associated with that part, or star element mass nodal definitions that are associated with that part. And quite often you have transference of mass through constrained nodal rigid bodies and so on. So there's loads of different ways that you can think about mass, and Primer can display all these different ways in the part table and present them to you, and you can investigate those quite easily. Now, assign mass is a tool in Primer that allows you to specify a group of parts, assembly of parts, and then say you want that assembly of parts to have particular mass properties. So you say you want it to be this total mass, you want it to have this C of G, or you want it to have this inertia tensor. And once you've specified that, Primer will calculate how it has to distribute masses over those parts to achieve the targets that you have specified. And once you've done that, these assigned mass definitions are stored within Primer, and it allows you to, for example, if you change the mesh of one of these parts, Primer knows that that part is part of this assigned mass definition and knows that it will have to recreate the element masses to recalculate the targets that you have specified. So it's a tool that allows you to manage mass over assemblies quite easily, and also to retain the integrity of the model when you change it. I just want to talk, getting towards the end now, I just want to talk a little bit about check customization, which has become quite popular over the last few years. So I touched on this earlier. There's various options. If you go to check in Primer, there's an options panel. Excuse me. And there's various options in there that affect the checks that you're doing, and you can turn on certain user-defined checks. So I've just got a couple of examples here. So here, for example, in the check options under the rigid section, there's things like rigid body merge max separation. So this is if you've got a constrained rigid body. It's an optional check that you can turn on. And in this case, it's turned on and the value is set to 150. And that means that if any constrained rigid bodies, the two sides of it are greater than 150 millimeters apart, it will be flagged up as an error when you do a model check. I mean, that's because it can be quite easy to create constrained rigid bodies that span across a vehicle, and sometimes you rigidify a big chunk of your vehicle without noticing it. Similar things for nodal rigid body max size and so on. So there's lots of different checks that are built into here that you can turn on, off, and customize checks in that way. Now, also, because there's so many checks in Primer, 7,000 plus, sometimes you might want to turn some of them off. Some of them might not be applicable to your particular requirements. And you can do that, and this is essentially saved in a little file called an error configuration file, where you can either promote or demote errors and warnings to your particular requirements. And this is a file that can live in a central place on your system where everyone in your team has access to it. So it's a way of promoting maybe warnings to an error, or demoting errors to a warning, or getting rid of things altogether. And then on top of that, this is not really covered by this webinar, but we have an internal scripting language based on JavaScript in Primer. And using that, you can create your own completely bespoke checks that you can run on nodes or parts of, for example. And again, these little scripts can live in a central area, and Primer will run these scripts when it's normal model checks, and they'll appear in the same check tree. So you can see how you might, when running checks, let's say you're running a check on an element shell, you've got some native checks built into Primer. You might, two of them, for example, you might not be bothered about. They're not important for your particular modeling guidelines or workflow or whatever. So you can remove those, but you can also add your own in as well. So you can see how you can build up your own checking, your own bespoke checking sort of framework that allows you to completely customize the checks in your particular way that suits your rules. Now, going on from that, we've also introduced the concept of a check dashboard in Primer. So this is something that's available under Tools, Check. You can activate this dashboard, and it's there to really give you an overall view on the health of your model. And if I can just explain some of these tiles. So here we've got an element quality check. So this tile relates to the element quality, and it will tell you whether there's any issues or not. And the second one along, which says model check, this is just the normal model check and lists whether you have any errors or warnings in your model. Next one along, the orange one, dyna output check. This is looking through any dyna output files, your D3HSP files and so on, and letting you know if there's any errors and warnings in there. This keyword cull check, this is if you're using any keywords or fields that are not supported in the version of Dyna you want to run in. That's what I was talking about before. And all the rest of them, you can have as many or as few of these tiles as you wish, because all these ones are, again, scripts that can be written that check your models in a particular way that is specific to your requirements. So we've got some examples here. On the second row, the first one says control cards. Control cards match company guidelines. So you can quite easily write a little script that checks to see if the models that you are creating has the control cards that are recommended within your company. Usually companies have particular guidelines for which control cards to use and which fields to set on particular control cards. So you can check for that in a script quite easily. And that script can return whether this tile will be green or red depending on what it finds. This element formulation check is checking for parts in your model that maybe are type 16 that don't have 5 integration points set on element formulation. So there's various things you can check for. And as I said, you can add as many or few of these tiles as you wish, and they're really there to allow you to build up a company-specific dashboard to give a visual indication on the health of your model. Now, I just want to finish off. This is the last thing I'm talking about today. Integration and pre and post processing. So I've talked about Primer a lot, but we also have some post processing tools. And with the Oasys products, you traditionally look at LS-DYNA input and files and output files separately. But it's often desirable to access both sets of information at the same time when you're checking your models. For example, maybe with output results, you want to look at material properties of a part that has failed or is showing some form of instability. So in version 15 onwards, there's ability to open one piece of software from another. So information is shared across Primer, D3plot, and THIS in a particular way that allows you to investigate information. If you're looking at results, you can investigate input information or vice versa. And the way this works is that it generally works best if you're looking at if you've got two monitors, and let's say you've got Primer open on one monitor. If we have some results files that relate to that particular keyword file, you can open it up in D3plot from Primer, and then you can move your model around interactively. And I'll just try and demo this very quickly. It's difficult to demo on one screen, but I shall try and do that. I've got a model here. And I've opened it on the left-hand side of my screen. If I click on the post button here, we've found some results files. So I'll click on Start D3plot. So that starts D3plot. Just opening up on my other screen. I'll bring it across in a second. So I'll just position that here. As I said, this works better on when you have multiple models. There we go. So I've got Primer and D3plot up at the same time. And if I go into Primer and just move my model around, hopefully you can see that in D3plot, the results are moving around at the same time. So it's a way of viewing both sets of information at the same time. And you can do various things here as well, like in D3plot here, I can right-click on a part and I can look at, for example, edit the part, so I can edit it in Primer. Or there's a part contact option, and this is a tool in Primer that for a particular part or group of parts will give you lots of information about what contacts those parts are in. It's often difficult to work out in a very big model with lots of contacts, which contacts a part is involved in. That can be a very expensive thing to have a part in lots of multiple contacts that overlap each other. So this is a way of checking that information. And it takes into account all the different ways of specifying it. Slave and master sides of parts, be it part sets or excluded sets and so on, defining boxes and not defining boxes and so on. Okay. So, I mean, that's brought me to the end of my talk. I just want to point you towards our new website. If you go to arup.com/dyna, we have a new website and there's lots of information on there that can help you out. Just wanted to point you towards Scriptbox. This is a new scripting repository. So if you are looking to get into scripting in our software, Scriptbox is there and it has lots of scripts that you can download, and you can also upload scripts as well. As I said, this webinar and all the previous webinars are recorded and are all freely available for you to access on our website. And there's lots of tutorials and workshops based around various aspects of our software that you can also access and download as well. Okay, so that's brought me to the end of the webinar. So I'm just going to check to see if we've had any questions. We've had a couple of questions. One says, many times LS-DYNA exits without an error message. How does read dyno or any other QA check help in that case? Well, that's a bit difficult. So what we hope is that if you run a normal model check in Primer, that if you go through all the errors that you get, that should ensure you have a reasonably clean model. And hopefully at that point, you could run your model successfully in LS-DYNA. If LS-DYNA crashes, then that's a different story. Yeah, I understand that Dyna sometimes crashes and doesn't give any error messages, and there's not a great deal of information that we can grab out of the text files to investigate those problems. But in those problems, you'd probably open it up in D3plot or postprocessor, THIS, and start looking at part energies and things like that. How to turn off a contour plot and get back to normal view. That's quite easy to do. So if I'm in Primer and I'm plotting something, I'm looking at a contour plot, you just press on either LI, HI, or SH in the view buttons down the bottom. That just gets you back to the normal view. And there's some keyboard shortcuts for that. So if you press S, so if I'm in contour mode and I use the keyboard shortcut S, it goes back to the normal shaded view. Encrypted materials can cause false positive errors. Could Primer create dummy models internally to overcome this issue? Yes, and there's a way that you can handle that. So in Primer, you can specify post star end keywords, and so these are keywords that you can write after star end, and they're called star encrypted cards, where you can specify certain basic information about materials. So you can specify material type, for example. So when you're working with encrypted models, maybe usually dummy models, things like that, all the material cards are encrypted. That means when you read it into model and run a model check, Primer doesn't know that a material is rigid or not, for example, because it's encrypted. And so you might get false negative errors or false positive errors about, constrained rigid body refers to this part and this part isn't rigid, because Primer doesn't know if it's rigid or not. So you can specify these post star end star encrypted cards. Primer will read them and use them in things like model check and maybe mass calculation if you specify a density. But it doesn't use them in the analysis because they're after star end. Now we have developed a script that you can use that automatically generates that information based on things like it looks at a particular part, for example, and looks to see if it's got rigid in the title. Quite often they do in these dummy models. Or it looks to see if it has any cross-references to things like joints or constrained rigid bodies. And if it does, then it assumes it's rigid. And once you run that script, it automatically generates these post-star end data and sticks them after. I think if you're interested in that, please do contact dyna.support at arup.com, and we can provide more information on that and point you towards where it is in the manual. And also we can send you examples of that and send you the script to allow you to use that. Next question is, what is an NAN error? So if you're talking about an NAN error in Dyna, that's, well, NAN is not a number. And you get that when Dyna has crashed for whatever reason. So I don't know why Dyna would crash, but in that particular example, but essentially it's doing some calculation where a number that it expects to be a number has for some reason become not a number. The next question, the range of numbering, how to set numbering range of a particular include file. So is this one? Yeah, so this example has got include ranges. So if you go to renumber includes, you get this panel. And here you can type in and specify the numbering ranges for each include file. It might be easier to type it in Excel, so you can write this information as a CSV file, type it in Excel, and then import that data into Primer. And then as soon as you've imported that data, Primer will check the entities within the include file to see whether they're in the specified range. And then if you click apply here, you can renumber those entities into the numbering range. And then from this point onwards, if you write the model out, these numbering ranges will be stored as comments at the top of the include file, so you don't have to keep on specifying it every single time. Okay, so that's brought me to the end of the questions. I'll just, if anyone has any quick questions they want to type in and ask. Nope, doesn't look like it. Okay then, we'll draw to a close. Thank you very much for attending the webinar today. Hopefully you found it useful. Please do, if you have any questions, any more further questions after this webinar, requests and so on, please do send them through to dyna.support at arup.com, or contact your local distributor and they'll be able to help you with any questions or requests that you may have. So there we go. Thank you very much, and hopefully see you again in future webinars.